Hello, thanks for checking out this session titled Keeping Time in the Global Workplace. I'm Greg Lane from Skeleton Key. Allow me to briefly introduce myself and then we'll dive in. At Skeleton Key, I manage a team of 15 certified developers and we build custom solutions for clients in practically every industry. I love FileMaker because it allows us to quickly build solutions that solve real problems. So here's the problem we're going to explore today. It's not a new problem, but as we move away from small local workgroups and toward cloud-based solutions with distributed teams, it's increasingly important for FileMaker developers to understand time from multiple perspectives. When all FileMaker users and their host use the same time zone, everyone has a consistent understanding of the dates and times in the system. However, when remote users are in different time zones, or when your host moves to a different time zone, dates and times can lose their meaning. For example, if users in New York and Los Angeles each create a record at the same moment, the creation timestamps for their records would be 3 hours apart. That might be acceptable in some systems, but could lead to chaos in others. In addition, all host evaluations of the date and time functions will be evaluated using the host's time zone. For example, if the solution is hosted with FileMaker Cloud, the host time zone is always Coordinated Universal Time, which is abbreviated as UTC. This is either 7 or 8 hours ahead of US Pacific time, depending on daylight savings time. So when records are created or modified by a server-side script or via the data API, the auto-enter values for these records will reflect the date and time of the host. Developers must consider the time zones of users and the host and design systems to ensure that date, time, and timestamp values are accurate and clearly presented. Daylight savings time rules are complex, and they are different in every location. Compare the times in Los Angeles and Phoenix on 2 different dates. Los Angeles currently switches between Pacific Standard Time and Pacific Daylight Time. However, Phoenix uses Mountain Standard Time year-round. When daylight savings time is in effect in Los Angeles, both cities share the same clock time. But for part of the year, clocks in Los Angeles are an hour earlier than Phoenix. The rules are too complex to express in a FileMaker calculation without a table of values. Consider these values for Phoenix. Like most of the United States before late 1883, Phoenix used local mean time, which was based on the average length of a day at a specific longitude. Then Phoenix switched to Mountain Standard Time, which is 7 hours earlier than UTC. In 1918, they began observing daylight savings time only sporadically, which meant they alternated between Mountain Standard Time and Mountain Daylight Time, until 1967 when a permanent change was made to Mountain Standard Time. You might also notice there was a period of time during World War II when Mountain War Time was in effect. This is actually one of the simplest sets of rules for any location within the United States. Most locations are significantly more complex. If your system stores historical or future timestamps and has users in multiple time zones, you must take extra steps to ensure that everyone understands the data. The session is all about helping you understand the issues and exploring strategies for building solutions. In this section, we'll explore how dates and times are stored in FileMaker, and we'll look at several built-in calculation functions for working with dates and times. Let's start with field types. The date field stores a date as the number of days since January 1 of the year 1. Time fields store a time as the number of seconds since midnight, and timestamp fields store a date and time together to reference a fixed point in time. Now internally, timestamp fields are stored as the number of seconds since midnight on January 1 of the year 1. It's important to understand that in FileMaker, timestamp values do not include time zone information. FileMaker has a set of get functions that will return various date and time values. getCurrentDate returns the current date according to the system calendar. Similar functions return the current time and the current timestamp. Another function called getCurrentHostTimestamp returns the host's current date and time according to the host system clock. The getCurrentTime UTC milliseconds function returns a number that represents the number of milliseconds since January 1 of the year 1. This value is based on the UTC time zone instead of the device's time zone. FileMaker also has a set of functions for creating and converting date and time values. The date function returns a date value for the specified parameters. Similar functions exist for time and timestamp. There are also functions for converting values, such as getAsDate, which converts a text or number value into a date value. There are similar functions for time and timestamp. It's important to understand the context in which functions are evaluated. Data can be modified by FileMaker Pro, FileMaker Go, and FileMaker WebDirect clients. But data can also be modified by various technologies on the host, including scheduled scripts, Perform Script on Server, the FileMaker Data API, FileMaker Custom Web Publishing with XML, FileMaker API for PHP, and ODBC and JDBC. FileMaker clients evaluate most of the get functions using the device's current time and time zone. An exception to this is the get current host timestamp function, which obviously uses the host clock and time zone. However, when functions are evaluated by any of the host technologies, the host's time and time zone are used. Now, this second point can't be emphasized enough. We've seen systems that were working great until they were moved to a host in a different time zone, and then suddenly server-side scripts no longer worked as intended. Now that we've reviewed the tools we have to work with dates and times in FileMaker, the next section will start to explore how to build a solution. In this section, we'll explore the changes that are needed to make a FileMaker solution work well for users in multiple time zones. Let's start by examining the situation. Where are users located? Do you have users in multiple time zones? Do any users travel outside of their normal time zone? What time zone does the host use? This setting might be configurable if you control the environment. In other cases, such as when you're using FileMaker Cloud, you won't be able to change it. Where are the values in each date, time, and timestamp field entered? Some values will only be edited by users, but in some cases, these may be auto-entered, modified by scripts, or even by external systems through APIs. More generally, you'll need to understand how the values in each date, time, and timestamp field are used so that you can provide an intuitive experience for all users. You're going to need to choose a time zone for your solution. We'll look at some specific scenarios in the next section. For performance reasons, you'll probably want to store all data within the solution in the same time zone, probably the time zone where most users are located. You'll want to add interface elements to show users their current time zone setting for the solution. Your solution should also detect changes in the user's time zone and either update itself or prompt the user to update settings. Next, make sure your solution is using the right kind of fields. Date, time, and timestamp fields are all valuable, but choose carefully. Date fields are best used for events that have a clear definition. For example, a birth date is always based on the birth location. An invoice date represents the date when a sale is recognized for accounting purposes. Time fields are best used for recording elapsed time or the time of day at a specific location. An elapsed time might be the length of a song or the duration of an event. Time of day is important for things like class schedules, which are likely the same time of day for an entire semester, regardless of the date or daylight savings time. Timestamps are best used to record the moment something occurred in the past or that is scheduled to occur in the future. Departure time, message sent, and record creation are each examples of a moment in time that should be recorded as a timestamp. Your solution may need several changes to allow users to view and work with their data in their current time zone. For instance, you can add unstored calculation fields for each timestamp to display the value for the users. Here's an example of such a calculation that uses a couple of custom functions. We'll discuss this and other custom functions in more detail later. Another way to accommodate the user's perspective is to modify find routines to allow the user to enter a local timestamp but have the find performed in the time zone defined for the field. Here's an example of a simple script that converts a value entered by a user into a value using the UTC time zone. In the next section, we'll look at 3 specific scenarios that put these solutions into practice. In this section, we're going to consider 3 scenarios. The first scenario is the simplest. The server and clients are configured for the same time zone, and all data is stored naturally in that time zone. In the second scenario, we'll store all of the data in the UTC time zone behind the scenes, but users will experience the data in their local time zone. The third scenario may be a better fit if the server and most users are in the same time zone. We'll store all of the data in that time zone, but we'll automatically convert timestamps for users who are connecting remotely from another time zone. In scenario 1, a local business has an on-premise FileMaker system. The server and all clients are configured with the same time zone. In this case, there's no need to convert data. The fields shown here are the default fields that FileMaker provides when creating a table. No special changes are needed since the date and time functions will evaluate consistently, and everyone understands their meaning. The same scenario can be used with a cloud-based server as long as you have the option of setting the server's time zone. In scenario 2, we have a FileMaker system hosted with FileMaker Cloud, but this could also be FileMaker Server using a UTC time zone. In this case, we're converting all timestamp data to UTC upon entry. Users edit, view, and search timestamp data in their local time zone. Because FileMaker Cloud always uses the UTC time zone, all host-based APIs and scripts will use UTC when the get functions are evaluated by the host. Let's take a closer look at how some of these fields are defined. The creation timestamp field has been modified as an auto-enter calculation that converts the get current time UTC milliseconds function into a timestamp. This will evaluate consistently regardless of the user's time zone. The modification timestamp is similar to the creation timestamp, except that we need to somehow update the value whenever the record is modified. The simplest way to do this is to use the evaluate function to trigger an update of the calculation when the modified by field is updated. Here's an example of an appointment timestamp field that is entered by a user. We want users to be able to enter timestamps using their local time zone, but we want to store those timestamps in UTC. The field is defined with an auto-enter calculation that converts the value entered by the user to UTC. In some of these calculations, you might notice that there are custom functions that do the heavy lifting. All of the calculations and custom functions are available in the Keeping Time example file, so you can dig into those to see how they work. For many of our timestamp fields, we'll want to display values to users in their local time zone. We can use unstored calculations for this, such as these three examples. By using conditional hiding and stacking fields, we can provide a seamless experience for users. However, keep in mind that these unstored calculations don't perform very well. We'll talk more about performance optimization later. Let's take a look at scenario 2 in action. We'll start by creating a new record in FileMaker Pro. The local time clock when this was recorded was about 7:20 p.m. Notice that the creation and modification timestamp fields show the timestamp as UTC values, and the local unstored calculation fields show the timestamp in my local time zone. When we enter a value in the appointment timestamp field, the value is converted into a UTC timestamp, and the local unstored calculation field shows the local time for the user. Now let's create a record via the Data API and confirm that timestamps are displayed as expected. We'll do the same thing with a record created via Perform Script on Server. Notice this date in November is after daylight savings time ends. The offset is calculated correctly at -6 hours as of that date instead of -5, which would be the offset today. Finally, let's provide a way for the user to enter a local timestamp and have that value converted to UTC so that a find can be performed on the indexed field. In our third scenario, most of the organization's employees are local, but some employees travel internationally and require remote access to the on-premise FileMaker server. In this example, we'll store all timestamp data using the headquarters time zone. For example, in this organization, if this organization was in St. Louis, we'd choose the America-Chicago time zone, which switches between Central Standard Time, which is UTC -6 hours, and Central Daylight Time, which is UTC -5 hours. This simplifies viewing and searching data and makes it easier to optimize performance for most users. However, it does require some additional development work to meet the needs of the traveling users. Host-based scripts are not affected, and developers are instructed to use the appropriate time zone when they access FileMaker APIs. Let's take a look at how some of these field definitions change when compared to our other scenarios. For the creation timestamp, we'll just auto-enter the current host timestamp. Easy. Similarly, for the modification timestamp, we'll use the evaluate function to enter the current host timestamp when the modified by field is updated. The auto-enter calc on our appointment timestamp field is a bit more complicated. We can use a little logic to optimize the calculation for most users. If the value is empty, we won't try to convert it. If the user's current time zone ID is the same as the HQ time zone ID, we don't need to convert the value because it is already in the time zone we want. Otherwise, we first convert the value entered by the user to UTC time, and then we convert that value to the HQ time zone. Similar logic is applied to the unstored calculation fields that are used to display the timestamps in traveling users' local time zone. For most users, these unstored calculation fields can be hidden so that they only see the original fields. In the next section, we'll talk more about the keeping time example file and discuss performance optimization. As we wrap up this session, let's talk a little about the keeping time example file and performance optimization. I built this example file to provide conceptual solutions that solve this problem in a very general way that could serve any group of users that need to work with both historical and future data. However, it is not optimized for production use, and you'll want to tailor it to your solution and its users. Consider ways to optimize the custom functions and calculations, such as delete any extra country, zone, and time zone records that will never be required by your system. The sample file includes worldwide data with over 100 years of historical time zone data and nearly 500 years of future time zone data. If you only need to support a small number of time zones, consider adding case functions in the custom functions for the most common time zones and avoid using execute SQL functions whenever possible. Look for opportunities to use perform script on server so that the server can do more of the work. Limit the number of localized timestamps that are displayed, particularly in lists and portals. You'll want to remember the user's selected time zone from their previous session and only prompt for time zone selection if their time zone has changed. But don't rely on just the onFirstWindowOpen script to set the time zone, because users may change time zones while they are connected to your solution. You'll also want to build checks into your navigation scripts to detect time zone changes and handle them appropriately. Now, don't oversimplify this solution. Daylight savings time rules make it difficult to solve this problem in a high-performance FileMaker native way, particularly when working with past and future data. Find the right balance between convenience, accuracy, performance, and development effort to provide users the optimum solution. Hopefully the tools and concepts in this session have equipped you to solve similar challenges in your own solution. If you have questions, feel free to reach out via the Claris community or at skeletonkey.com. To download the sample file, please visit our website at skeletonkey.com/keepingtime.